Hey guys, it's EJ with Blockpad, and today in our final video in our video series on arrays, we're going to take a look at inline programs and for loops in those inline programs. In this video, I wanted to focus on the array aspect of inline programs, specifically for loops, but there is a good bit of background information that you're going to need to know to learn how to work with them, so we're going to cover that first. Now, inline programs, they work essentially like little mini programming scripts inside of an equation. So I have two examples here, and if I double click this to edit the equation, you can see how I have this defined. So first, I have program, the keyword, and then open and close curly braces, and then inside of that is going to be the program definition. Then on the left side of the equal sign here, I just have the name and equal sign like I would with any equation. Now, in these inline programs, Blockpad functions and math and all of the value types are going to work just like in regular equations. So you can have arrays with brackets, you can have numbers with units, text, all of the functions for manipulating those values, all of that is going to work the same. But there are a handful of differences that you need to know since this is more like a programming script than it is just an individual value or equation. So the first is that these values and matrix items can be overwritten inside of a program. So if I double click this, you'll see that I have b equals 4 meters, and then below that I have b equals 4 feet. And so my result is going to use that 4 feet value, and it's just going to totally ignore the 4 meters value because it was overwritten. Also, you can use array indexing to overwrite specific items in an array. So inside of this equation, I define an array with brackets, and then I use array indexing to overwrite a value instead of just reading it. So here where I have array of 2 equals 10, that's going to overwrite the second item in the array. So you can see in my final result that that's going to be 10 and not 2. Similarly here I have array of 4 equals array of 4 times 3. So this is going to be the previous fourth item in the array, so 4 times 3. So my new fourth item is going to be 12. Press enter. The next thing you need to know is that semicolons will mark the end of a programming line. So if I open this back up, you see I have these semicolons at the end of each line. And that's because even though I have these in separate lines for better readability, it doesn't need to be that way. So if I backspace and put these all on the same line, press enter, it's still going to work the same because it's that semicolon that's marking the end of the line. Next is that the last line of the program is used as the output for the equation. So here, the last line is C, and so 5 feet, the result of C, is going to be my actual output. If I change this to A, then my output is going to be 3 feet. So for example, if I come here and say hypotenuse times 3, it's using that 3 feet value. I don't even have to use something that's in the program. I could just say 16 pounds, and because that's what's on the last line, that's going to be my output. So that's an important thing to note that you want your output there to be the last line. Similarly for here, my array example, array is the last line. Next is that if-else statements are going to work in addition to the regular if function. So I have a little thing on if-else statements here. I don't want to get too in-depth into this, but this is going to be the basic syntax, which essentially matches how JavaScript if-else statements work. So you'll have the if condition, in curly braces, what to do if true. Then you can also tack on else and else ifs to that original if statement. And so here I have an example of using an if and else statement. And then also an example of using an if function that does the same thing as my if else example. Now, because this is pretty simple, it's kind of clear how you would use the if function. You just use these nested ifs. But even for more complicated things, a lot of times the if function will work if you start to get created with calling custom functions as the results to your if functions. So moving on, the last thing that I'm going to talk about in inline programs is our two types of for loops that are available. Now, the types of for loops we have are for in loops and index-based or C-style for loops. The for in loops are very similar to for loops in Python, and you're going to define them like this here. You'll use the keyword for, open parentheses, the keyword var or var, and then here you're going to specify the name that's going to correspond to the items in the array that you're going to loop through. And that can be any name. It doesn't have to be anything specific. It's just what you're going to use inside of the for loop. Then the keyword in, and then the array that you're going to loop through. So in this style of for loop, you're going to provide an array, and then it's going to go through each item in that array, and you're going to do something using that item. And then open and close curly braces that are going to specify what to do inside of the loop. So just as a really simple example, I have for, their step in steps array, and then inside the curly braces, I have a, which is just going to be some other array. Indexed using the step is going to equal step squared. And as I said, this could be anything. I can name this I can name this item, could be whatever. And this is just going to be the name of the array that you're looping through. Next, we have index-based for loops, and these are specified like this. You have the keyword for, and then open parentheses. Then you're going to specify the initial value along with the name you're going to use for that. So here I'll have step equals 1. Then the condition, and while the condition is true, you're going to go on to the next loop. So here I have step is less than or equal to 3. So once step becomes greater than 3, the looping is going to stop. And then here I have step at end. That's going to be the change that you make to the initial value at the end of each loop that will eventually get your condition to break. In this case, I have step plus plus. And then for what to do in the loop, I have a of step, same kind of parentheses indexing equals step squared. And these loops are very similar to JavaScript or C++ or a lot of other common programming languages. To illustrate how to use these for loops, I have 3 very simple examples that are going to recreate something in Blockpad that we already have a function for, but just in the interest of keeping it simple, we're going to show that. So I have this array, nums, and the first thing we're going to do is square every item. So I'm going to click into this. You see I have the keyword program, then open and close curly braces. In the first line, I have the result array equals open and close brackets. And this is just creating an empty array. Next, I have this for in loop where I have for item in nums. So I'm going to loop through each item in nums. Then I have open curly braces and close for what to do in the for loop. And I have result array equals concat items of result array and item squared. So this is going to take the previous value of result array and concatenate items squared into that. So if before I had an empty array, it's going to add item squared as the first item. And then when I loop through it the next time, and I just have that first value, I'm going to add item squared as the next value. And then so on and so forth until we're finished. We've looped through all the items in nums. And then I'm going to return that res array as my answer. Like we covered in our last video, if you didn't want to touch for loops, we have a lot of functional alternatives to that, including the each and reduce function. And so here I have an example of squaring every item using this each function. Of course, in this particular case, item by item calculations are also going to work. So I could just say nums squared, and then that's going to give me the same exact result. Moving on, to calculate the sum of squares, I have this program here. And again, I'm going to start with the keyword program with open and close curly braces. For my first line, I have this value res equals 0. Then I'm going to use the index-based for loop where I have for I equals 1. And note that I'm starting on 1 here and not on 0 like you typically would in a lot of other programming languages. And that's because Blockpad's parentheses indexing is indexed to 1 and not to 0. So that's an important thing to note if you're used to JavaScript or something like that. So for I equals 1, I is less than or equal to count all of nums, and then I equals I plus 1, which is a step we're going to do at the end. So once I has 1 added to it enough times that it's greater than the count all of nums, then our for loop's going to stop. So for each of those steps, we have res equals res plus nums of I squared. And remember, nums of I, this is just parentheses indexing using this I value. So it's going to get the first item, then the second, then the third, then the fourth. And each time it's going to add it on to the res value and then overwrite that res value. And then for our output, we just have this res value, and that's what it's going to output. For the functional alternative, I would use reduce here, just like the example in the last video, which I'll put a link to in the description. For this last simple example, we're going to look at max. I'll open it up. Again, we have program. And then for this initial line, I'm going to have max num equals nums of 1. So this is the first item in the nums array. And I don't want to make it 0 like I did for sum of squares, because if all of the items in nums were negative, then we'd get 0 as the answer. Which would be incorrect. So again, I'm using this index-based for loop. You could probably also use a for in loop, but for this example, I'm using this index-based. So I have for I equals 2, and we're starting on 2 because we already have 1 accounted for. And then I is less than or equal to count all of nums, just like in our last example. I equals I plus 1, just like in our last example. And then I have max num equals, using the if function, if max num is greater than or equal to the nums index, then return max num, otherwise return that item from nums. And that's really it. At the end, I'll return max num. I will also add that if you just have one line in your for loop, you don't actually need the curly braces around it. So for example, if I remove the curly braces here, then this is going to work the exact same. And then for the functional alternative, we would use reduce in the same way that we covered in our last video. Finally, I wanted to mention that what I think is the best use of these inline programs is to create custom functions and then use those custom functions throughout your document. That way you can keep all of the complexity that's happening inside of these inline programs in one sort of contained space, and then use them as a custom function like you would just regular functions in Blockpad. So as an example here, say sometimes I needed to get every other item from an array. There's not a built-in Blockpad function to do that, but you can create your own using inline programming. And I'll click into this so that you can get a look at what's going on here. I'm not going to explain this in detail, but you can see how I've got this defined. And then when I run this every other item function on A, then I get that every other item. So I think this is a great use of inline programs, but even then, you can use functional methods like we covered in the last video to define these custom functions as well. So for example, I have this every other item too, and when I use that on A, that's going to give me the same result as the original every other item that I had defined. Just to handle that in a very readable way, I have these nested custom functions where I define null every other item first, so to get an idea of what's going on there. Then I'm going to get a null value for every other item. So I do that using the each function and the if function. So I've got this if function here. And then I call that null every other item function inside of my final definition, where I use the where function to get rid of those null values. So that's just a suggestion for a good way, I think, to handle these more complex array things, to create a custom function that you can just use regularly. And that's all I've got for you guys in this video. Like I said, this is the final planned video for our video series on arrays. If there are any other videos that you'd like to see on arrays, please let us know in the comments. And also let me know if you have any questions, and I'd be happy to answer them. And that's all I've got. Thank you.